today we'll be looking at Module 4, Lesson 27, one-step equations just like yesterday, except today we're going to look at multiplication and division, where yesterday we looked at addition and subtraction, okay? So let's start right off the bat with example 1. Solve 3z equals 9 using tape diagrams and algebraically, then check your answer. Okay, so 3z equals 9. What operation is in there? What does that mean, 3z? Everybody? Multiplication. It's 3 times z. So first let's draw two tape diagrams to represent each side of the equation. Alright, so first I have 9. And what is equal to 9? 3z's are equal to 9. Now, if I wanted to take that 9 and split it into 3 groups, so it matches the other tape diagram, how big would each group be? 3. Yeah, it wasn't a trick question. 3. So now let's demonstrate the value of z using tape diagrams. Well, I know that I had 3 groups of z. And I also know that if I take that 9 and separate it into 3 groups, that each group would be 3. So then I can see that z equals 3. Okay, any questions on where that came from? To z. Those are z's, sorry. So now how would we demonstrate that algebraically? If that was a multiplication expression, how do we get that identity back? I don't want to know what 3 z's are. I want to know what 1 z is. So I want to find the identity or the value of just z. So if this is a multiplication equation, what do I do to get the identity?
Z minus 3 plus 3 equals...
Well, not minus in addition. You're on the right track, but you're on the wrong operation. I'm going to use the inverse. Right, I'm going to divide. Because the inverse of multiplication is division. So if this is 3z, which is multiplication, the inverse is division. So I'm going to divide by 3. But my equation's not going to be equal anymore. If I change one side of the equal sign, I have to change the other side of the equal sign. Otherwise, it's not going to be equal anymore. So it was 9, but now I have to divide it by 3. So I had to do the inverse on both sides of the equation.
we also write it as a fraction.
No. We want to write it across like that.
How will we figure out to divide 3z by?
Because division is the inverse of multiplication, and you're going to use the number that's with it.
So we want to do divided by z, we do divided by 3.
Right, because we want to find the value of z, so the z is what we want there, left alone. So how do we use this to get the value of z? Well, let's see, on the left side, the left side of the equation will equal z. Because we know the identity property let's review what the identity property is. A times B divided by B will equal A. So we showed an example of what the identity property is. and we're going to apply it to the left side of the equation. Now on the right side, will be 3, because 9 divided by 3 equals 3. Therefore, the value of z is 3. So now how are we going to replace our answer? Oops, I just told you the answer. The answer to this question, how can we check our answer? Can you repeat that, please? How are we going to check? How did we check yesterday?
You're going to do 3 equals 9 and 3 times 3 equals 9.
Okay, so we're going to substitute. Substitute the value of z in the original equation. So if it was 3z equals 9, I know that z was 3. So I replace z with 3. 3 times 3 is 9. 9 equals 9, so that's a true statement. So I know that it's a correct answer, that z does equal 3, because that makes that a true sentence. Okay? Questions? All right. Let's try one with division now. Okay? Solve y divided by 4 equals 2 using tape diagrams and algebraically. Then, check your answer. So first, let's draw 2 tape diagrams to represent each side of the equation. So what do we know from this? We know that y divided by 4 equals 2. So y divided by 4 equals 2. Draw that in your notes. Okay. Now, if this first tape diagram shows the size of y divided by 4, how can we draw a tape diagram to represent y? So think about what y would be if this is y after it was divided by 4. Well, let's take a look at this pizza to help us. This pizza was divided by 4, correct? So here is a piece of it. This is y after it was divided by 4. If I wanted to show the whole pizza, I'm over here. If I wanted to show the whole pizza, what would I have to do? This is pizza divided by 4. That's pizza divided by 4. So what would I have to do to show the whole pizza? If I wanted to show the whole pizza, what would I have to do? How many pieces of this would I need? Everybody? Total pieces. 4. So to show all of y, what do I have to do? How many of those do I need? How many of these do I need to represent y? 4. Actually, I should have moved this down. So the tape diagram, God bless. to represent y should be 4 sections of y divided by 4. So that's how we can find the tape diagram of y. Does everybody see that? Because y divided by 4. Okay? Now, how can we use this? Let's use this tape diagram. Let's take a picture of it. See if it worked. It didn't work. I'm trying to get all fancy. Now it's not working. Uh-oh. Alrighty. No, pause. They can't pause the recording. Oh, please hold. We're experiencing technical difficulties. I can't pause it. I can't pause it. The screen is frozen. So if y divided by 4 equals 2, if y divided by 4 equals 2, what is each one of these sections equal to? Each y divided by 4 is equal to 2. So if each one of these is equal to 2, what is all of y equal to? 8. So I have 4 groups of 8. Okay, so you can draw 4 more boxes underneath. You can draw a box here. That would be 2. A box here. That would be 2. And so on. So continue that in your notes. Where? I don't want to reset the whole thing though.
Just like unfreeze.
Let's see if this will work.
That was just sign. That was on the I was watching people play.
Oh, here we go. Okay. Yay. All right, so let's go back to where we were. Should I even bother to try this again? So this was our tape diagram. All right, back at it now. So what does the value of each section represent? We know that each one is, what do we know from the beginning? We know that each one is equal to 2. We saw that here, that each one was equal to 2. So what does y equal? Y equals 8. All right. Now, how would we do this algebraically? Well, if it's y divided by 4 equals 2, what's the inverse operation of division? Multiplication. So I have to multiply both sides by what to find the value of y? Right now, y is being divided by 4. I want to put it back together. So what would I have to do? What's the inverse? Y multiplied by what? I want the y alone. I don't want that there. 4. So I have to multiply both sides by 4. So that leaves us with y equals 8. Same thing as the tape diagram. So the left side will equal y. And the right will equal 8. So now to check it, we write the original equation. And wherever I see y, I'm going to replace it with 8 because I know y equals 8. That's the value of y. 8 divided by 4 is 2. 2 equals 2. So by substituting y with 8, it made the statement true. So that is the solution. Okay? Any questions on where any of these numbers came from? Alright, I want you to try to draw a tape diagram for this one on your own, and then we'll go over it. Okay, 3m equals 21. So first let's show what we have. So I have 21 and 3m's. The boxes should try to be the same size. I should fix that so they're the same. So now I'm going to take my 21 and separate it into 3 boxes so that it's equal with the m's. So what should I separate 21 into 3 boxes? What would the value of each one be? 7. So I could see that m equals 7. Now I know that I have to check it. So to check it, I write my original equation, 3m equals 21. Replace m with 7. 21 equals 21, so that makes that statement true. Questions on that? All right, let's try division 1. Try that one. They want you to solve this one algebraically. So if it's division, what is the inverse operation that you're going to use? Multiplication. And what am I going to multiply both sides by? I want to find the value of the n. I want to get my n alone. And if it's being divided by 5, how am I going to get it back again to be n? How do I get the identity? If it's being divided by 5, now I have to multiply it by 5. So if I'm going to multiply that side by 5, I have to multiply that side by 5. So n divided by 5 times 5 equals n. That's our identity property. 5 times 15 is 75. So n equals 75. Now I have to check it. So 15 equals n divided by 5. Wherever I see n, I'm going to replace it with 75. I don't want to do that mentally. I might want to come over to the margin and check that. I don't want to assume that those are going to be equal. The whole point of the check is to find a mistake that maybe you made when you were solving it algebraically. So 15 does equal 15, so that's a true statement. So that does equal 75. Okay? Try one more. That I could do both before the bell rings. All right. So 36 and 4 p's. So now I'm going to take my 36 and break it into 4 sections. So what's 36 separated into 4 sections? What's 36 divided by 4? 9. Well, that's not confusing looking at all. So P equals 9. If you were going to do that algebraically, 4P equals 36. 4 times P divided by 4 equals 36 divided by 4. I have to do the inverse to both sides. So that leaves me with P, 36 divided by 4 is 9. So both methods gave me 9. So now to quickly check it, 4P equals 36. 4 times 9 is 36. 36 equals 36. So tonight for your homework, make sure you read the directions carefully and use the method they told you to use. And make sure that you show your checks as well.